Okay, so now we're doing parallel circuits, but this is a slightly more sophisticated circuit, and we have resistors 1 and 2 have different values, and so the math gets a little bit more difficult here. So I'm going to work through this problem and then give you a practice problem to do. So we start by finding the total resistance. The total resistance is equal to 1 over R1 plus 1 over R2. It's going to be 1 over 5 plus 1 over 10. So here we need to find a common denominator, which is going to be 10. So we multiply both the top numerator and denominator by 2 to get 10 there. So we have 2 over 10 plus 1 over 10. That's going to be 2 plus 1. So that means 1 over RT is going to be 3 over 10. So now we need to flip this side and flip this side to get RT over 1. RT over 1 is going to be 10 over 3, or you can say RT is equal to 10 over 3, which is really 3 1/3, but we're going to keep it in this format right here. Okay. It's a little bit messy, so I'm going to redo that. Okay, so here is our RT. We're going to put this, we're going to put this up here. Okay, and now we have this is our total voltage, we have our total resistance, and so now we can find our total current. So I'm going to erase all this. Okay, so now we have VT, your total voltage, is equal to your total current times your total resistance. And we just put in the values. For VT, we have 60. For your current, we don't know, that's our variable. And then for the resistance, it's 10 over 3. Okay, so now we're going to multiply both sides. Well, now we need to try to get this value, IT, by itself. Well, how would we do that? Well, we won't do that by trying to get this to go away, right? How would we get that to go away? Well, we can do that by multiplying by the reciprocal. To get this to go away, we would need 10 in the denominator to cancel with the 10 in the numerator, and we would put 3 up here to cancel with the 3 in the denominator. So now we have this cancels with this, and those become 1. This cancels with this, and those both become 1. So now we have, but whatever we do to the right side of the equation, we have to do the same thing to the left to keep it balanced. So since we multiplied the right side by 3/10, we have to multiply the left side by 3/10. Okay? So now we have 3 over 10 times 60, but just to make it nice and neat, I'm going to do 60 over 1 to keep it lined up. And that's going to be equal to IT. And that's going to be 1 times 1 over 1 times 1, which is just 1. So now if we reduce the left side of the equation, we can say, oh, 60 is divisible by 10 and 10 is divisible by 10. So we can divide those both by 10. This becomes 6 and this becomes 1. So now we have 3 over 1 times 6 over 1 is equal to IT times 1, right? So now we can go 3 times 6 is 18 over 1 times 1 is 1 is equal to IT. And 18 divided by 1 is just 18. So that means IT equals 18 amps. Okay, so now we can come up here and we can say, oh, our total current is 18 amps. Oh, and this is ohms. Okay, now in a parallel circuit, we know that the voltage stays the same everywhere. So that means that this is 60 volts and this is 60 volts. So now we can locally look at this area and we can say, oh, let's use our main equation, which is V equal IR. But now it's locally. V1 is equal to I1 times R1. Our V1 is 60. Our I1 we don't know. And our R is 5. So now if we divide both sides by 5, we get I1 is equal to 60 divided by 5, which is 12 amps. Now if I look over here, I can try to do this locally. So now we have V2 is equal to I2R2. Our V2 is 60. Our I2, I don't know. And our R2 is 10. Divide both sides by 10, and we get I2 is equal to 6 amps. And that makes sense because look at it. This resistor here is 5 ohms and this one's 10. And this one has more resistance over here, which means it's going to have greater current. Here's 6 and here's 12. Okay? So we have 12 amps coming up this way, right? And we have 6 amps coming this way. They join together to make 18 amps because 12 plus 6 is 18. And you can see that's exactly what we have down here. Okay, so now I'm going to erase a lot of this and I'm going to give you a practice problem. So I'm going to make this a little bigger and just erase this. Okay. Sorry, this is taking so long. You can speed this up if you want. Okay. So now, let's say if we have R1 is equal to 4 ohms, and R2 is equal to 8 ohms, then let's make this 24 volts. Okay, so go ahead and pause the video and try to solve it. Okay, so now I'm going to solve it so you can check your answers. 1 over RT is equal to 1 over R1 plus 1 over R2. We have 1 over RT is equal to 1 over 4 plus 1 over 8. Create a common denominator, which is going to be 8. It's going to be 2 8s plus 1 8 is 3 8s. So 1 over RT is equal to 3 over 8. So now we flip this side, and we have RT over 1 is equal to 8 over 3. So that is our total voltage. Their total resistance, excuse me. 8 over 3 ohms. Okay, now how do you solve for total current? You know total voltage is equal to total current times total resistance. And we plug this in. 24 is equal to IT times 8 over 3. Okay, now this, the math looks a little bit scary. Not too bad, but a little bit scary. Oopsie, where'd it go? We've been having issues with things disappearing. Guess I'll have to rewrite it. Okay, so we have 24 is equal to IT times 8 over 3. Okay, so now we want to get this by itself. So we have to multiply this side by the reciprocal. And then we multiply the other side by the reciprocal. And so we can see this cancels with this cancels with this. So these all become 1. And we have over on the side 3 8 times 24 is equal to your total current. And we can write this, if it makes it easier for you to think about it, as 24 over 1. So now we look at this and we can say, oh, 8 and 24 are both divisible by 8. So if we divide 8 by 8, we get 1. If we divide 24 by 8, we get 3. 3 times 3 is 9. So 9 is equal to IT. So here, we can say IT is equal to 9 amps. Now, voltage stays the same everywhere, so V1 is equal to 24 volts, and V2 is equal to 24 volts. So then you have V1 is equal to I1 R1. So you have 24 is equal to I1 times 4. Divide both sides by 4, you get I1 is equal to 6 amps. Here you have V2 is equal to I2 R2. So you have 24 is equal to I2 times 8. Divide both sides by 8. You get I2 is equal to 3 amps. So here we have the, see, wrong. Here we have R1, V1, I1, R2, V2, oopsie, V2, I2, VT, total resistance, and total current. And we have units on everything, so everything is solved. Thank you.